Well, hello and welcome to my shop, and thank you for joining me here today. It is May 30th. Not a bad day today, I think. So yesterday, when I put the video together from yesterday's work, I was stunned to find out it was 2 hours I'd spent in here plus. So let the good times roll. Now, I don't plan to do another 2-hour video here today. I think what I'm going to do today is we're just going to play this radio and check it out for how well it performs. Yesterday's video ended with me playing a little bit of AM radio, thinking I had it attached to an outdoor antenna, but in fact it was never attached to an outdoor antenna, so its performance was based on a lead wire that was hooked up to it, nothing much more. So we can use the proper antenna today and find out a lot more about its operation, how it works on the different bands, and maybe even poke around with these very unusual push-button self-tuning arrangement that the radio has, which I'm happy to say I think I understand how it works. I was pondering it and suddenly realized what they were probably doing with the automatic powered tuning. So right now the fuse is out to the motor here, so the motor cannot operate, so I don't have to worry about that right now. I think what we'll do is we'll play the radio and try some different bands and see what we can pick up. Now it's not even 9 o'clock in the morning here, so what's on shortwave? There isn't much anyway to begin with anymore. Once we're fiddled around with the radio a bit, we'll take a closer look at this automatic tuning feature and maybe even experiment with that a little bit. Just put the fuse in and see what happens. Okay, there's too much more to be said. Might as well just start tuning around. Okay, I think I got everything in order. The coffee is brewing and I've switched on the antenna down here. Now right now I only have the live wire connected. The ground wire is not connected to the radio. And we'll start like that. Volume down, switch is on. Good, everything's ready to go. Here we go. I don't have it plugged in. Oh, a logistics problem. How am I going to plug this in? Plug it in. Be able to see the device here. Does it reach? Did I put enough long enough wire on this? Yeah. Okay. Power is off at the moment. Plug it in. Okay, here we go. So I'm switching it on with the dim bulbs because I'm a little cautious. Very good. The hum is the speaker. Excellent. Just listening very carefully to it. Antenna off. Didn't make any difference. Why would that be? Radio's running at only 100 volts. Let's just go a little higher with it. It's 105. That should be good enough. So why so different than yesterday? Band switch, dirty band switch. The spring is not retracting this back. That's why the string was dismounted up here. There should be a spring in here that is pulling on it all the time. Something not right here. I'm pretty sure we heard it work, didn't we? Yesterday. With no antenna. Okay, so the band is on band A, which is the broadcast band. What's changed here? No antenna connected. There's a lot of bad wires back there. So A2, I think, is the shortwave antenna connection. A1 is missing in action back here. Nothing's making any noise. I'm sure this worked yesterday. Oh, what just happened now? Oh my gosh. What is going on here? I don't remember the strong hum. It's a big bad hum. And there's one end. Whoa!
So we air it on the screen? Yes, everybody loved the Christmas lights. I also was the Boy Scout. That's always that is the so you know, like what Diet Coke today back in
both of these controls are not cleaning up, or at least they don't stop making that sound. It's probably due to DC going through the controls. I can't be sure of that. I have to study the schematic to know for sure. That's a very loud hum, isn't it? That's a really loud hum. Pretty dirty band switch here. That's a mean hum. Why are you humming so much? Kind of a buzzy hum. Now, this can start a fire. Okay. Now, how about that horrifying hum? I don't know why the strong hum. Let's carry on, just check out the reception. Doesn't seem to be anything bad happening to the radio. So. This is strange, this sound. The fact that it's picking up this French, this is a local station in French. That's pretty good. That's pretty good reception. Except for the hum. The crazy hum. Volume independent hum. Okay, so we'll try the next band, which would be, oops, this is dismounted already. There is a, well, I think there's a spring in here. It needs a little lubrication to get going again, that's all. This is the 6 megahertz band. We wouldn't expect to pick anything up at this time of day on this band. So one end. It's one end. So I'm listening for atmospheric type noise, things like that. Reassure me it's receiving something. Okay, go to our next band. This is a 9 megahertz band. You notice right away a lot of the sound just disappeared. So it's still there, but weaker. We could pick something up here. Maybe. Maybe not. Nope. Okay. Go to the next band. This is 11 megahertz, I think. Turn it way up now. Nobody home there. Okay, next band. Not sure where we are here. 19 meter band. Are we at the end of the run? We are. Okay, 19 meter band, 15 megahertz. Can't hear the. There we are. Well, disappointing. We didn't pick up anything anywhere. So I'm going to shut this off so we don't have to listen to that terrible hum, which I don't recall that being there yesterday. Was it there yesterday like that? So the bad reception is not too much of a concern. I think it's a wrong time of day, and the radio's not been tuned up in any way. It's got all these bad capacitors in it. It would be a surprise that it doesn't pick anything up, but also there isn't a lot to pick up anymore. I hate to say that. I hate to admit that, in fact. But there's just not a lot on shortwave these days that you can get in North America anyway. By the time the evening comes here, say 9, 10 o'clock in the evening here, it's very late in Europe, and their broadcasting is going down. Even though there is shortwave broadcasting in Europe, it's tricky to pick up here in the first place. It's not aimed at us. And plus they're all going to sleep. So, and everybody's ignoring North America for shortwave, because nobody in North America listens to shortwave in a serious way, except maybe some religious people listen to it. I don't know. And nutcases like me and others playing around with these radios are listening. Okay, that wasn't the best result, but the hum has got me a little bit concerned. But the next thing to investigate is this fantastic motor system in here. And first, I think I'm going to stop for a bit, and then I'm going to try to explain to you how I think it works. I could be wrong, but I think I got it. And then we'll take a look at on the radio, the parts and whatnot. We'll look on the schematic. Then I'll put the fuse in and see what happens. Okay, let's take a look at the radio here, how it's okay, there we go. What is going on with this? Looks a lot better since the dust is off it. So there's a plate here that is directly on the shaft of the capacitor. So capacitor turns, plate turns. Plate has a split in it somewhere. I don't see. I got the radio. Let's tune the radio to the sort of a middle position here. So you can see something coming up here. Can you tell it's a wide, it looks like a paint mixing stick, in fact. Goes down through the shaft to the other side. This plate and this plate are two different plates. They don't quite touch right here. And this piece of wood, or whatever it is supporting the plates, keeping them separate. So you have two half plates with an insulator in between. Doing this. Now here's what I'm going to suggest. One plate is connected to the motor in such a way that if it's energized, the motor will turn in a certain direction. The other plate, if it's energized or contacted or whatever, it will turn the motor in the other direction. That's the key thing. So if you supply current to the motor through, let's say, this contact, which is touching this plate, and the motor comes on, and the reason this is going is because you've pushed a button in the front. The motor turns on, and the plate will start rotating with the split coming towards the energized contact. And when the dead spot, or the insulated spot between the two plates, reaches this, then the current will be cut off from the motor will stop. The brainchild about this is the problem of when you first push the button, the radio may be tuned to the left or tuned to the right of the target station. So the motor may have to turn to the left or to the right in order to drive the tuning mechanism to the spot you want it. How can it know ahead of time which way things are? How can you switch the power to the motor so it reverses the motor's directions appropriately? You do it with a split plate. So if you think about it for a minute, if the motor's designed and the wiring's designed so that if this is energized through here to the motor will turn the plate this way. But if we ahead of time turn the plate all the way to here and then turn the motor on, it's on this plate, it's now being, the motor's driven in reverse, and things will operate in the opposite direction, and again the split will approach the contact, the source contact. We can call this the source contact, I guess. There's two grooves here simply because there's so many of these things and they can't cross each other. So I think that's the only reason there are so many of them. Now how do you adjust these? There's a pretty heavy spring in here, obviously pushing and clamping it. Well, you know, it just looks like you'd somehow relax the spring and then move the thing around, but I'm going to leave it like it is because probably in instructions it's going to explain exactly how to do it. Just looking at all these cracked wires here. I'm going to have to get to those pretty soon. These are actually these are going right to the plates. So under my theory, this would be carrying motor current. Oh, I don't know if we want to operate it like that. These are almost certain to make a short somewhere, short to ground or somewhere I can't see. They go straight to the motor. Very easy to replace these, I think. Maybe a little tricky getting up in here. Yeah, a little tricky up in here. You can do it though. So operating this with these cracked wires, would it be crazy to do that? Are they really taking the motor power? Sure looks like it, like it's going right to the motor here. Motor power, so these things have to be able to switch motor power. That has to be a pretty good contact to carry the current to drive a motor. It's only for a short while, but... So what did they make this plate out of? Because they must have made it out of something that's not going to corrode or become non-conductive. And it does look like, as I've been tuning the radio, these things have been pushing on the plate and scraping it, so maybe it's cleaned itself up. How do these get into the position they're in? I'm thinking, you know, the buttons come with what look, well, they're not here, what look like factory placed stickers. But most of the time, these things are designed so that you can pick where you want this to be. I mean, it can't be just as easy as just grabbing this and moving it. No, these are really strong springs in here. Maybe there's some kind of tool that you grab them with and move them that is missing. Like I say, I've got some instructions to look through. We'll probably find it out. Now, they have to, you know, to do this, to get any precision on it, this can't be a string-driven mechanism. And it isn't. It's just right on the drive shaft of the capacitor, right on the wheel here. Interesting. Very interesting. So I think probably we'd have to replace these wires. Got to replace them anyway, sooner or later, so probably now's the time to do it. Just put in some alternate wires. What more could you tell about the motor? So there's quite a batch of wires coming through here. And they're all heading up into here, and they're coming from these switches. You can see the wires going up in here. So we look at these switches now. Okay, the radio's not plugged in, so These are not simple. Let's take a closer look with another camera here. I may have to stop and fix the focus on this camera. It's not. Well, maybe it is fixed. Maybe it's fixed like this. Are you auto-focusing, camera? I can't really tell. Okay, so let's look at these from this distance. There's a copper band here with all these fingers. And then there's something else in here beside it. I gotta change the focus on this camera because we need it to be up closer. So bear with me just a moment here while I do that. Did it just focus? It did, didn't it? Well, I'm still going to go ahead and put it on manual focus here because the autofocus is very annoying. Okay, there we are. It's fixed focus now. Go back and look at these things some more. Hold still, everybody. So a lot going on here. So they're hitting this. So that's either just stopping it. This is part of the metal of the radio. Oh, look at this! Look at this! Look at this! Huh. I know what that is. Push the switch hard enough and it'll lock. Like that. You push the next switch, so there's always some kind of apparatus like this in these buttons. You push the next switch and the first thing it does is it releases the other switch. And then you lock that one in. Okay, so when they're locked in, let's release it here. Boing. What is actually switching? Where's the actual switch action here? Push it all the way. At what point does the switch close? And what's this piece next to it here? Watch it carefully. So it looks like when you push this, you're pushing a piece that's underneath this, pushing it away from it. Yeah, see, it opened. But yeah, I would expect the switch to close, not open. And in this position, these are all closed. And I remember on the schematic, it showed how each of these switches has to be closed to carry something all the way down to the open switch. That's a lot of contacts that have to work. So when you push this one, you push this, open the one switch, and then the others will have opened. Open the switch. Okay, well, okay, that's the observation. You push the button, you open a switch and break a circuit. Maybe you're opening it here and closing something else I haven't seen yet that's in behind here. Somehow, let's look at the wiring. How much wire? Oh, okay, all kinds of wires coming up here. So these would be the individual button wires coming along. All the way down here, something here. It's not in the same position as all the rest. See, there's some metal plates sandwiched between non-conductive, these brown cardboardy, woody sort of layers. Is that what that is? I don't know, but it's some kind of insulative material. When we get down to this end, we get to a real... This is where all the connections are made for something. I was on my way to saying something like I knew what I was going to say, but I had no idea what I'm going to say here. You gotta kind of fish the wire in there. Okay, okay, so we kind of know structurally what this is and where the wires are, and kind of rough idea how it operates. I don't think there's much. Well, the one thing about the motor, I was going to say, I don't think there's much about the motor we can figure out. But the one thing is, when the motor's not in use, you don't want it to be engaged. Although, you know what? This is the easiest turning part in this whole radio. If this stayed engaged, you'd never know it. There's a spring in there, I see. So that spring would act to push this back, but I think there's no springiness left in it because this is not going back. But like I say, it's the smoothest moving piece in the whole radio. So you think you energize the motor, it'll be thrust forward to engage with this. What happens if it strikes there? So I definitely think there's a spring problem there. Let's pull it back. If I tune the radio. When you tune the radio, you're turning a lot of stuff here. But see, it's pretty oiled up. Who oiled this thing? They didn't get the dust off it very well either. Maybe we'll clean that up and can lubricate this a little bit, but does it need any? And what I'm thinking is put the fuse in, let this baby go, but I think I really do wonder where the brushes are in this motor. The bushings feel good. Okay, I think I got the plan here. That's right, Cat. It's pretty clear. What I've got to do is change those wires to the motor, put the fuse in, and we'll gamble around, we'll poke around with it. I can keep the voltage low on the set, and so we don't take too much risk. We'll see what that motor does. What do you say, Bert? Good idea? Look at his tail there. You see a happy cat. That's a happy cat. His tail's going to break off if he bends it up any higher. Right? Are you happy? Are you walking on my keyboard again? Hello, are we still on? And he's going to go investigate the radio over there. Okay, I know what I got to do. I'm going to go do it. Come on, Bert, let's go have some fun. Get off my keyboard. Well, thank you very much to the person who sent me this, or a link to the Pacific TV website. Pacific TV is on the west coast of Canada, and they maintain an excellent list of Canadian schematics, and a fantastic source for those of us who are trying to do this kind of stuff. So here's something I really haven't seen. I just glanced at it. So let's see what's in here. Model 68, model. So these are different models. Model G, 116 RCA models. So I think what's happening is a couple of companies are making the same basic radio and they're numbering it differently. So the RCA is calling it a 911 KG in my case, but you could have I think Canadian General Electric, I think, G117 is the same thing. Whoops, does it show it up here at the very top? Go away. That little bar would go away up there, but it won't. Okay. Oh, there we are. I don't know. In any case, this is our area here. Let's look at this. So there's a magic eye, a range indicator. All these here. Doesn't quite say which one is which one you push for phono and which one. I can't read the thing, but maybe we'll find out a little further down here. The left-hand key is a record player attachment switch. The right-hand key is for manual tuning. Aha! So just as I had hoped. So if we push this, then the phono input comes live, and if we push this, we're using the tuning knob. Right-hand key is for manual tuning. There's the range selector, tuning, volume, soft, loud, soft. Can sound be soft? Yes, of course. Okay, left-hand key. Station setting contacts, brass selector disc. That's that split disc. Oh, insulation line. They even point it right out. Insulation line. Black lead from station key number 1. Long center wire in cable. Okay, long center wire in cable. Solder to station setting contacts. Well, why would they say that? I mean, they're instructing the guy in the factory to solder it. What's going on there? Remote control unit. This doesn't look like much. So we have a wire, a long wire coming to this. And so something's coming down here, and you close the switch, and it's going back up here to number one over here. So these wires probably continue into this bundle, and they show up. This would be number 1 here with no wire on it for some reason. Why would they not show a wire coming here? Probably just oversight. And so basically you close the switch. We know they lock in place. When they lock in place, they energize, say this one, may close switch 5, energize post 5, applies power to the plate, and the plate starts rotating until the insulation line meets here, and then power's cut to the motor, it stops. Chances are you still have to fine-tune the radio at that point. I'm not sure they would promise that this thing will tune it exactly on the money. Probably doesn't. But it gets you right there, probably close enough that you can hear the station involved. And you can just touch it up a little bit. Turn range selector to 8-band. Turn power on. Allow a few minutes. What is this? What is this? What are we reading here? Instructions on. Make a list of the desired 8 stations arranged in order from low to high frequencies. Press down the manual tuning right-hand key. Manually tune the first station on the list using the tuning eye for accurate tuning. Hold down the manual tuning key and press down station key number 1. Both keys will stay down. Move station setting contact number 1 to the insulating line on the disc, because the disc is now positioned in the right place to tune that station. So you would move this. Now it doesn't say how to move it, it just says move it. How do you move it? Move it. When the contact is correctly centered on the insulating line, the central dial lamp will go out. But isn't the motor running? Isn't the motor running when you do this? They don't mention the motor. press down on any other key. Oh my gosh, guess who's pressing down on the keys here? Okay, hold on. My cat just walked on the keyboard before I could turn it off. We've had a complete disaster. How many things did he do here? I don't know. Here, okay. You can walk on it now because I've turned it off. Go ahead. Walk away there, cat. Manually tune in the first station on the list using the tuning eye. Hold down the manual tuning key and press down the station key number 1. Both keys will stay down. Move station setting contact number 1 to the insulating line in the rig end. When the contact is correctly centered, the dial lamp will go out. But when it's not centered, won't the motor be going? Press down on any other key in order to release the manual tuning key and station number 1. Then press down station number 1 again. The electric tuning mechanism will function to tune the station, and the central dial lamp will stay on. Will stay on. So it looks like when you have this manual tuning key pushed down, it shuts the motor off, so the motor won't operate. That's why you have to have this key number 1 down. Then everything's manual, and then it says oh, my cat is right in front of my screen now. Come on. I can't see a thing. Oh my God, you're so big now. Look. Well, you know how cats do that kind of thing? Can I possibly? I can't even. Oh, now he's on my keyboard. Get your arse out of here, cat. Come on. Oh, okay. Down you go. Okay, well, what was I doing? Press down the other key in order to release the manual tuning key and station 1. Then press down station 1 again. This time the manual tuning key is up. The electric tuning mechanism will function. So that's what's going on. Repeat this process. But when it says move it, they don't explain how to move it. Because it didn't look like an easy thing to move these little guys around. Are you coming around again, cat? It's coming around again. This is for another radio. So that's all we get on this page, but wow, that's very, very helpful. Okay, really got a good idea now what's going on with the automatic tuning. Are we ready to experiment with it? What was the next thing I was going to do? Can't remember. Okay, let's take a look at the schematic here around the motor itself, which is all down in here. We'll see what we can figure out from looking at it here. Just zoom in. There's a little more here than just a schematic too. There's some more information to look at. So there we see the rotating disc with the insulating section here. They're showing it stop. Well, they're showing it in a vertical position, but it's stopped on this particular one. They've color coded all these: black, brown, blue, green, red. Good luck seeing these colors on those wires now. Here's the dial tuning one. This is the one that we now know also when you push dial tuning, you open the motor circuit somehow. Probably if we looked at this long enough, we'd see how it's done. When I look at this, I think what they're trying to show here is there's a winding in one direction and a winding in the other direction. I think that's what they're trying to portray here. Tuning motor. They don't really say too much more about it, do they? But you can see how one plate is tied to this and the other plate is tied to this. So I think that's a pretty safe bet. That's what's really going on there. We've got some capacitors here. These might be noise limiting capacitors because the motor has brushes. So when it runs, it's going to spark a little bit. It's going to actually generate noise right in the radio. So that's probably what this is. Spark suppression of some sort. Then this is also part of it, I think. Yeah, this is the very first. Ooh, what's it say there? C49. Well, that's a capacitor. I thought it meant 49 meter band at first. So this is also the special button. It's different than all the rest. So this one's special and this one's special. Wait a minute. Wait a minute. They call this button 1. What is this? They show the connection right to the Victrola jack. What if you, just imagine back in the day, you're in the factory, this radio's just been finished, it just went through its final testing, and it's sitting there. and the technician's getting ready to do the next radio, and you come running up with a Bluetooth receiver, and you tell them, hey, we can plug this Bluetooth receiver into the back of the radio here, and then see my phone. You pull out your phone and show them your phone, and then we're going to be able to just pick some music here. Look, I'm just going to touch the screen here. The screen? Touching the screen? Oh my God! At this point, the guy would probably be running for the hills. You'd think you're from another planet. And that, you know, I like to think of these things because it helps me understand where I am in the world, and you too. We're living beyond the Jetsons here, and we may not even realize it. So I guess that's what I'm trying to do, is realize these things, make them real. Anyway, going back to this button, not to get too carried away. Well, it says switch 7. This whole thing, does it have a switch number? I don't see one. Switch 7. Victrola. Well, I think it's just, you know, it's got the push button symbol here. It must just be the most left button, and they didn't number it. Of course, they want to number these in relationship to what's on the back of this disc. I think that's really what this numbering is really about. That's why they didn't number these either. Station selector dial lamp. Okay, I didn't quite catch how this works, but it looks like maybe, I don't know. Maybe I don't know. Looks like the dial lamp is independently switched on at the same time the motor is enabled. Maybe that's what it's indicating to you, that you're operating the radio in a motor-enabled mode. Well, I guess the idea is you're going to push down a button, like they show this one, push down. You push down this button, it locks in place, and you just leave it like that. And the radio motor runs, and then it reaches this point and stops, and the radio continues on. You just leave this pushed down. You never need to push it up again, but I bet you if you push this button, this one will pop up. If you push this button, probably the same thing, it'll pop up. This looks totally different how they're showing this. Okay, I'm just going to take a peek in the radio here and just see if that first button does look totally different from all the rest. And I'd say, at a glance in the darkness here, just look closer. Yeah, you know what? It is different. It is different. This actually exists. And when you push this button, you are pushing these two contacts over here. So it does look different. And this is to turn on the phono and probably turn off the radio, which, you know, makes common sense. But some of these radios, when you turn on the phono, you don't turn the radio off. You have to tune between stations. The really, really cheap radios are like that. Okay, now where's the fuse? So if we follow this motor wiring and look for some kind of fuse on the line. Ooh, look at that, 24 volts. Oh, so it's a 24 volt motor. And I'm not seeing any fuse in here anywhere. I haven't seen one, and I'm not seeing one now. It doesn't appear to be an afterthought because the fuse is mounted and the terminals are passed through the chassis through insulated sleeves. It looks like it's an engineered thing. Maybe it's a later addition. Maybe after a couple of fires they decided to start putting a fuse in here. I don't know. You'd have to sit and think for a while about how can this go wrong? Can the motor reach a state where it just runs endlessly, where it's blocked, where it can't rotate, but it's energized? Could that kind of stuff happen? That's why they would want to put a fuse in. And of course, you know, anything can happen. If you're going to make thousands of these radios, and I don't know how many of these they would have made, but it'd be a substantial number, then you've got to start thinking about the odds. What are the odds of one of them doing this kind of thing? You know, the motor going crazy. You know, with one radio, the odds are low. Thousands of radios, the odds get really high that one of them's going to do something weird. So you have to take some steps to secure the radio because you're manufacturing it in numbers. Whereas if it was a one-off, okay, for some reason I started gawking up here. I don't know why, because I'm just talking aimlessly. I think what I'm doing is I have this psychological pattern where I delay scary steps. I don't want to take them, so I find myself delaying them. Now let's look at the power. So nothing here at all. No capacitors, nothing going on here. Okay, I'm gonna have a little coffee, and then we're gonna seriously consider operating the motor in this radio. Okay, we want to pick a better fuse than this 30 amp one, and I have a few fuses here that have come my way over the years. Now, what we want here. I would say a 5 amp fuse should do the trick. 5 amp fuse. Looks like this one here. Don't spill those. Any cat around? No. Size? Yeah. And size again. Five amps. I think that's a better size. Now, if it pops, could be just from the motor's initial draw. Maybe it's really crazy high or something. Maybe that's why they got a 30 amp in there. But 30 amp isn't going to protect anything. Might as well not have a fuse. And now the cat's here, and they put away this precarious collection of fuses before he puts them away. And that's only a small portion of the fuses. I have just a stupid number of fuses you wouldn't believe. Okay, this is the one we want. Now, any reason to try doing something without the fuse in there? Would there be any benefit? I don't think so offhand. So we're going to pop this fuse in to the radio. No, it's up on top. Of course it would be up on top where you can get at it. Okay. Okay, fuse is in. If it pops, like I was almost saying, if it pops, it's probably because, I don't know why. Because it could be because of bad, defective motor. Or, oh, look at this. We gotta close that off. Don't start it like that. Do I need to hook up the speaker to do this test? If I don't hook up the speaker, then it leaves much of the radio de-energized, which is okay. I think that's okay. Yeah, I'll leave the speaker off for now. And just looking at this cord to make sure it's not worse than I thought. Well, it's definitely worse than I thought. Well, no, wait a minute. I don't know if am I seeing wire there or what am I seeing? I should just cut this and put a new plug on right away. I can see copper there. Okay, so we're going to deal with this plug situation too. The cord itself is actually in pretty good shape. It's very stiff here, but then it gets flexible just back here. So we are going to go back here. Oh, I hope I got a new plug. I thought I just came across one the other day, and what did I do with it? What did I do with the brand new plug? Okay, I'm going to stop the video while I hunt down the, how do I even do that? Yeah, I can hunt down the plug. Where's the plug? Oh, I decided I might as well put a whole new wire on, power wire on, and this may crack something. Look, there's a crack right here. So I mean, this is not going to last. Yeah, new wire. Here's what I wanted to show you though. One end of this goes to the switch. The other end often is attached just kind of airborne to the primary wires. These are the primary wires, stiff as can be here. And here's, you can't see it here, can you? Can you see it? Just behind here is a taped connection. So I have to remake this. There's no terminal. It's not soldered to a terminal. Pretty. Wow, I can hear these crack as I bend them around. So I have an option here. I can cut this and attach the new cable straight to this red wire, or I can leave this. This is in good shape. The connection that was done. This is done with friction tape. It's very good. The wire's reasonably flexible here. So it might be better for me to actually work with this wire. I'm going to cut a length of it here. Give myself lots to work with. Okay, now what I'm doing is I'm taking an old extension cord, which is in good shape, and I'm going to cut the end off of it. And this is the one we're going to hook up in here. A good way to strain relief this. I can see there's some holes here in the chassis. I should be able to utilize that to strain relief this better than the original. So we're going to want one end. Can you see how much easier it is to work with? This is all flexible here. If I'm trying to work with this, this is not flexible, so I'm better off to do it. Join like that, join like that. There's no polarity in the radio, but it's a polarized plug. This doesn't matter. We already looked on the extension. We looked on the schematic, and I can see right here there is no connection to the chassis in any way, shape, or form. It just feeds the primary on the transformer and nothing else. Okay, we need to put this one back too. Good show. Okay, bring this over. Let's put it behind here. Let's put it behind this capacitor. Okay. Big one. Too big? I think that's just the size. I don't have one. Anything smaller is way smaller. So this will probably shrink down enough. A little long. Blue. Okay, we'll fire this up. Here. That. It's a lot here to heat up. copper conducts the heat really quickly. There's a heavy copper wire, so the heat is being conducted away very quickly. There we go. Isn't that a pleasant smell? Okay. Try not to burn my hand on it. I should have put this in behind. That's okay. Because I'm going to put the radio in, it's going to push on it right here a little bit. It would have been better if I got it behind this red wire. Can I still do that? I can still do that. It's all flexible. It's all flexible. Oh, who's coming? Coming to see what's going on here. Okay, and I should have slid the shrink sleeve around onto it. There. Okay. Now we can make this connection. What is it, Bert? You should go hang around with your brother. Our third cat, our older black cat, is outside because she's an outside cat, so she goes out. Actually, she's not outside, come to think of it. But they don't get along well. The two orange guys and the black one, black girl, they don't really get along that well. Uh-oh, are you walking on my keyboard? Are we still operating here? Hello, testing. Yeah. Okay, so this will end any concern about the power cord, if there ever was any. Now I gotta shrink that. So, let me get a hold of this guy here. Away. We just have to shrink this enough that it won't slide, and it's not likely to slide anyway. It's not going to slide now. Let's see if I can just make it look a little better. Okay, there we go. Cool down. Okay, we have a new cord in. I do need to strain relieve it, but I don't want to do it with the radio up like this right now. We have the fuse, we have the cord. The question is, do we have the kahunas to turn this thing? Try it. Okay, cleaning up the bench here. That means I'm getting ready for excitement, potential excitement. Don't want too much stuff on my bench because a certain level of panic can ensue during something like this. And if your bench is covered with stuff and you're in a panic, it ain't gonna go well. And what are you doing over here? Playing with these clips here. Here, look at this. See this? There he goes. Okay, he's off and out of here. Should I tip this down to do this? Any reason for that? No, I think we want to see what happens with this motor. We want to see it spin. We want to see it do this thing. We want to see that. Okay, push buttons are all released. We know now this is the phono dial. This isn't pushed in. Does this have to be like nothing is pushed in? Should there always be at least one thing pushed in on this? I don't think there was before. So why? So the reason you need to push this switch primarily is to release any of these other ones. But once you push it, it's locked in, isn't it? Oh, it doesn't lock. Oh, yes, it does. It does lock. Well, that's quite mysterious to me now. What are you locking in there? Okay, we'll do a little experimenting and find out. Okay, volume down. Switch is on. We're all ready to go here. Fuse is in. No reason for that motor to work right off the bat. If it does, we're in trouble. Okay, there we go. Very good. And we do not have the speaker plugged in, so we're not going to hear anything. And most of the radio is essentially dead in a sense. The tubes will all heat up, but there'll be no current going through any of them. What am I waiting for now? I'm just nervous about doing this. That's what it is. Plus, I got to put my finger right on this copper piece here. Radio's plugged into an isolation transformer. I'm standing on one foot right now. My shoes are insulated. I mean, I'm really not going to get a shock, but just the idea of pushing the contact itself is a little hairy. So we don't know, actually, because I don't have the speaker in, we don't know about what goes on here. The other thing too is I'm supplying it with low voltage, which 90, which is not a good idea, I think, at this point. Let's put it on higher current. It's probably going to be a higher 110 volts. Okay, we don't want to run the motor with too little current. So there's really nothing more to do than push the button. Maybe what we should do is try to figure out, and I don't think I can, which button is going to cause the shortest motor operation. I don't think I can do that. The capacitor is mostly, it's not in the center, it's mostly towards one side. You know what I could do? I could turn the set off, push a switch, and then energize the radio. Why would that be a mistake? I don't think that's a mistake. I think that's a good idea, because I can immediately de-energize the radio if something weird happens. But what expectation is, well, let's de-energize it. So expectation is, I'll push one of these in. The motor should come to life as soon as I apply power. The rotor should shoot this way and engage here and start spinning. And it should spin. We have to see this, I think. You're going to want to watch the spin rate. So we're going to want to watch this separation right here. Watch which way it's moving. And I've pushed one of the buttons kind of in the middle of the button set. So I don't know. Who knows which one of these it is. Before we do this, just take another look at these wires, which are so terrible. I said I would have to replace them, but I haven't yet. Are they going to cause a big problem? Because I'm pretty sure they're carrying motor current. Well, I think we're okay. Okay. Famous last words. So, I hit the power here. Over here, you can see my finger on the switch. Motor turns for a time, and well, we need to see both this thing turning and the motor operating. So you can see this here now. I can't delay this any longer. Doing like drum roll, countdown, flash glasses, hearing protection. Here we go. Boy, if it engages now, it would be a bad thing. So probably a little lubrication issue there, although this is really smoothly operating. Why the funny speed thing? And it did not do this at all. What is supposed to make it do that? I thought I saw a spring in here. light's up in here. There's none there. The spring compresses when you do this. So for sure, I'm sure the way this is supposed to work. Motor comes on and the rotor is pulled into the motor. See, it's out here, pulled into the motor by the magnetism. And then when the motor turns off, the spring pushes it back. This thing has to be strong enough to pull it against a spring, and it can't even pull it against no spring. Not a good sign. So this time I'm going to engage this right in here. We're going to turn it on again, this time with it engaged, and we're going to let it do its thing. Did it get warm at all? No, nothing really bad happened. What about throwing a little lubrication in there right now? Why not? Sure. I mean, it just doesn't feel like any lubrication is needed, but this is that's air. This is a very light oil, putting a very small amount on. Someday I'm going to squeeze this bottle and it's just going to blow open and I'm going to have oil everywhere. Okay, it's engaged. So this time the thinking is it's going to operate the capacitor. It's going to turn the whole mechanism until it stops on its own. That's what we're hoping will happen. Okay, you can see the motor. Maybe it's going to disengage right away. You can see the plate and the little bump right there. You can see watch that. Okay, we're ready. Okay, so oh, she's trying to engage. And it did go back, because it wouldn't take much of a spring to push this back while the rotor is spinning, because the friction has been almost nothing. So it sort of pulled itself forward, but not quite. Okay, and I got it up on its side. Would it work better if it were in a proper position? I kind of doubt that. Unfortunately, it disengaged. Now what if we keep it engaged? I'm going to make it engage. Push it with this. We'll keep it engaged and see if it doesn't operate all the way. Okay, so I'm going to put this, just takes a little bit of pressure here. Which way was it spinning? Like that. And watching everything. You can see the wheel, you can see the motor. Don't really have to see the motor anymore because I'm manually holding it in place. We really want to see this wheel turning. What if it doesn't stop? What if it just goes right past and just keeps right on going? If it goes past, it should change direction, so it would start doing this kind of thing. And I got my hand on the switch anyway. Okay, here we go. This motor's really weak. Come on, baby, put some torque. This kind of motor, I think, is known for being torqueless. I saw these wires moving. Whoa, whoa, whoa! Don't engage at that speed. Warp speed there. Here we go again. It's not. Oh, maybe it's in the spot. Is it in the spot? I think it's in the spot. Who's in the spot now? This one. This one's in the spot. Yeah, it is. So this is probably the guy we energized. Already be it's practically working. Okay, let me manually tune this so that it's on the other side. So I'm moving the brake down here. Now this thing should rotate the other way. That's the scheme. Do you rotate the other way? There we go. This isn't the best thing. just a piece of wood. Fire one. Going the same way, isn't it? Okay, I think that's enough experimenting with this for now. I think I've made a number of important observations. One is, it's a weak motor. Why would it be weak? Magnets are worn out in it. Does it really have magnets in it? Let me unplug this. I'm sure it does. Doesn't it have to have magnets in it? Maybe not. Didn't I say, okay, that's enough for the motor for now? The spring is in there. Weak spring, weak motor. Yeah, see? The spring push it back. Then we energize it, it should pull it in. It's definitely working this way. So basically the mechanism all works. The motor works, everything works. It's just the motor's not strong, and I don't know what you can do about that offhand. Other than make sure everything is well lubricated and easy to turn. This thing is not easy to turn. And it's very heavily geared here. So, you know, what kind of pushback is there here? Not much. It wouldn't take much to turn this. Extensive gearing. So you can see that because it's snapping back, how let go. That's because the rest of the mechanism is not moving, and you're just building up some stress in the string somewhere or something like that. So just feeling this. Well, there is a normal lubricating thing that should be done with these radios anyway. I think I'm gonna dust this off here because it's really I missed that earlier. I'm just putting a little WD-40 here and there wherever I think there might be some drag. It's actually a lot of drag in this knob. Now that I think about it, it's not coming from this. Can you see if I wiggle the knob? Watch this wheel here. See it wiggling back and forth, but not actually rotating. So this wheel is being held. What's it being held by? Well, guess what? This gigantic mechanism at the back with all these pins on it dragging on this plate. That's a lot of stuff. So we have a bearing up in here. A bearing in the back here. Turn it this way. There's also sliding ground contacts in these capacitors. Whoa, I put a lot in there. It's so hard to control this stuff. But that's just, I think I'm feeling the pressure of these contacts on that plate. Where's that squeak coming from? The string is very tight, and so even these things might have some friction. What am I missing? Oh, the classic one. What does he mean by that? Let's go around this way, this way. It's the, oh no, I would have got it in here. The classic one is these knobs often come into a sleeve that sticks in the radio about this far. There's no mechanism in most radios, right? It's just a sleeve. Now that sleeve often is the source of all the drag in the tuning. If you notice too, they're using the U-shaped valley technique here. these are important observations, because if things aren't right, you need to kind of have a mental picture of what is really going on. So this particular radio uses a U-shaped bobbin here, if I can call it that. And the idea is the string crawls as you turn it. It tends to crawl across the shaft. In the case of the U-shaped one, it starts climbing up the U, but it can't. Well, the string is only so long, so if it starts climbing up, it starts increasing the tension of the string. So there's a lot pulling it back down, and it will stay down, and instead the whole bundle will slide this way. This is the idea of it. These things get in trouble. Like this one's got a lot of dirt on it, but it does seem to work. Yeah, see, do you see it just go back? You can feel this in the knob. Like if you're playing with a radio and you're turning the knob, you feel funny things going on. It could be this. The worst case is the string will climb up the side and then fall over onto the bundle and start tying kind of a knot. When that happens, you're dialing this radio, maybe you're at a yard sale or something, and you get partway across, and it doesn't come to a sudden stop, but it suddenly tightens up. And you're starting to pull against the spring up here. The hint is it's doubling over here. So in some radios they make this really long and the string can just walk back and forth, but then that can cause derailing on the other components because the string is moving too far back and forth. So plus, if you have the string too tight, this string is probably a little bit too tight. I don't know if you can tell, but this wheel is tipped this way. I think it's pulled down so hard. Let's see, is it just warped? Well, it might just be a little warped. You can see the string is starting to, it's on its way to dismounting right in here. I don't think it's going to happen though. Okay, amazing the string hasn't broken yet. I'm waiting for that to happen. It has not broken. So we've lubricated everything. But still, you know, I can see how, well, it's really heavily geared here. So why even a weak motor? How weak is this motor? I should block it and feel it. But I think we can see it's pretty weak because I have blocked it. And I blocked it with this. And it took nothing to stop it. How do you jack up a motor like this? So there's a capacitor associated with it, but I think it's a noise reduction capacitor. I don't think it's a... some of these motors have trouble starting, like a record player motor. And almost no torque at the very start, so they have to play a trick. And I'm not sure that trick is being played here. That could be what these are. These could be the trick to cause a motor to be unbalanced magnetically right at the start, and then it'll rotate a bit, and that's enough to get it going because it has almost no torque, these motors. I think this is the same. I think it's like a record player motor here, torqueless, and that's why you saw it too. I first turned it on, it went very slow, but then finally, when it finally got itself loosened up inside, away it went at a high speed. It's another indication of just almost no torque in the motor. Well, let's try it again. I have thrown a little bit of lubrication here and there. I can't imagine it's going to work, but let's try it again because it's too much fun to not do. Let me just fix something back here. Okay. That way the screams of pleasure can't be heard when everything starts working perfectly here. So we're ready to apply power. We have a button down, but we know it's in the satisfied rate. Oh, is it? It should be. So what if I turn it on, motor doesn't come on, push a button, motor comes on and everything works? Should we try that? Let's try that. Okay, here we go. And the motor's going. How come the motor's going? Whoa! I just think if it engages at that speed, this should be snapping in right away. And again, maybe that's another indication of weakness in the motor. Okay, once again, I will try. I don't know what is the least friction way to do this. Okay, there we go. Yeah, see, look at it just touches it. Once it gets going, it'll have torque. It's changing direction. Look at this, the motor's changing direction. and now it's in the neutral spot. Okay, we're going to push a button now. I don't want to touch the chassis when I do this. No! Whack, 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 whack. Oh, that's interesting. Did you see it go back and forth there? It was like hunting for a minute. It's actually doing the job. Let's try another button. Okay, I want to keep this in though. Another button. How cool is that? It goes like this. That's just what people do. Whoop. Didn't want that to happen. Okay. Interesting. I think we've learned a lot here about how this mechanism is supposed to operate and how it does work in this radio. Pretty cool. How can we make it work consistently? Great. So, you know what? That's it for today. Make sure I got the power off here. That's it for today. I discovered enough about this radio now today. So tomorrow I will pull the fuse, ignore this motor for a while, and we'll start dealing with all these capacitors. And we'll start working in the audio circuits. We'll feed an audio signal into the phono and listen to what it sounds like, and then we'll go after the capacitors. We'll look for incorrect grid potentials and stuff like that, and slowly clean out the capacitors. That's the plan. Thanks a lot for watching today, and see you tomorrow.